This is a very important lecture. It's about a process that we will use throughout chemistry and actually beyond general chemistry. It is dimensional analysis, which simply is a fancy phrase for converting one set of units to another set of units. There's a process that you should go through to do this. Many of the problems that you will see will be easy enough for you to do in your head, but you must show your work. Just as in math, when you're in chemistry, anytime you have a calculation, you have to show your work and units in order to get full credit. It's especially important in dimensional analysis that you include the units as you do your calculation. You will see that's because the purpose of dimensional analysis is changing units, so you really need to keep track of the units in your beginning number and your conversion factors so that you can make sure you have arranged everything correctly. So first of all, let's talk about what we mean by a conversion factor. A conversion factor is what allows you to change your units from one value, let's say inches, into a different value, in this case centimeters. If you're going to do that, you need a conversion factor or an equality which shows you the relationship between the two units. In dimensional analysis, we will take these equalities and arrange them in ratio form, okay, with one of the units on top and the other on bottom. It's important how you arrange this conversion factor, as you will see in our examples, so that the old units cancel out. Here's kind of a skeleton template for you to use. You will always start with the information given to you in the problem. So let's say you're given inches, certain amount of inches in a problem, and asked to convert to centimeters. So you will start with the inches given you in the problem. Then you will find your conversion factor. You need to make sure that the units in your conversion factor in the denominator match the same units in your given information so that those units cancel out. So in this case, you would want inches on the bottom, and whatever units you're trying to get to, which let's say are centimeters, in the top. Then you cancel out the old units, and your answer will now be in the units you're looking for, which would be the units on the numerator of your conversion factor. Let's do a really simple example. How many minutes are there in 2.5 hours? The first thing you need to get used to is identifying what is the given information. It will always be a number with a certain unit. Always put that first when you're showing your work, 2.5 hours. Then you need the conversion factor between hours and minutes. We know that there are 60 minutes in 1 hour. That is your equality. When you arrange it in a ratio form, it is your conversion factor. Since the units of your beginning given information are hours, you want to make sure that your conversion factor has hours in the denominator. Hours then can cancel, and now you simply have a math problem, which is 2.5 times 60, and that equals 150. The units of your answer are the units that have not canceled out, in this case minutes. Here's another example. A rattlesnake is 2.44 meters long. Now, back in our measurement and unit lecture, I told you that you will need to convert between different metric units and that you need to know the most common prefixes. This would be one example of that. So once you memorize those conversions, you will hopefully know that 100 centimeters equals 1 meter. So that is your conversion factor. Start with the given information. Arrange your conversion factor so that the units in the denominator match the given units. Cancel those units out. Now we have a multiplication problem, 2.44 times 100. That equals 244 centimeters. Now, your dimensional analysis, those were simple problems that you could likely just do in your head, But I want you to use that method because you are going to end up with some dimensional analysis problems that are multi-step and are too difficult to do in your head. So let's do a rather simple example of a multi-step. How many seconds are 1.4 days? Well, it's unlikely that you are just going to have the conversion factor between seconds and days laying around in your head. What I would do, I know that there are 60 seconds in 1 minute, and I know there are 60 minutes in 1 hour, and I know there are 24 hours in 1 day. So I would probably do a 3-step calculation using each of these to get to the units I want, which are days. So again, start with the original given information, which is 1.4 days. Make sure that your first conversion factor has days in the denominator so that days cancel out. Now, look at the units you have not canceled, in this case hour. You need another conversion factor that's going to cancel your hours out, and you will end up with minutes. One more step, convert minutes to seconds. Now you end up with a multiplication problem, 1.4 times 24 times 60 times 60. Now, something here, some students forget about their denominators. In all the examples we've done so far, the denominator only has the number 1. That will not always be the case. So be very careful to also include your denominator. When you multiply all those and divide all those together, here's the answer you get. Your units will be the final units you have in the numerator. All right, so let's see if you can do this one on your own. Go ahead and read the question and stop the video for a couple minutes, see if you can work it on your own, and then you can compare your answer to mine. Did you get 3.6 feet per second for your answer? Let's go ahead and see how that's done. It's also important in this unit to report all of your answers with the correct number of sig figs, so let me start reminding you of that also. Start with the given information, which is 65 meters per minute. So we are trying to go from units of meters per minute to feet per second. This can get quite tricky. So the bottom line is we're trying to convert meters to feet and minutes to second. What I've shown here is working it all out on one fell swoop, but sometimes I prefer to separate it out. So let me show you what I mean. 65 meters per minute. I'm not even going to think about the denominator yet. I'm just going to try to convert these meters to feet. So I know that the conversion factor for meters to feet was given to me, and I also know that meters has to be the units in the denominator of my conversion factor, and there's a 1 in front of meter, and then in the top 3.28 feet. I'm going to go ahead and cancel out my meters. And now if I were to stop at this point, my units would be feet per minute. And that, if I were to calculate that, I would get 213.2 feet per minute. I'm not paying attention to sig figs. All right, so then I would say, well, I don't need feet per minute, I need feet per second. So then I would go on to do a second step. If you're comfortable and you understand doing it all in one step, that's perfectly fine. I'm just breaking it down for some people who would rather do it stepwise. All right, so now we have 213.2 feet per minute, and I want to get rid of the minute and convert it to seconds. So in this case, in order to cancel out minutes, I need to put minutes on the top up here so that they cancel. and I know that there's 1 minute in 60 seconds. All right, so now I've canceled out minutes, and I will have seconds in the denominator. So now my answer is 213.2 feet divided by 60 seconds. So if I do that calculation, I get 3.553 feet per second. And now I've got to worry about significant figures. So I have to go back and look at the numbers that I've used to determine how many significant figures to report the answer in. If you look back at the original problem, the given information was 65 meters per minute. All right, so that only has 2 sig figs, and any type of dimensional analysis, you are multiplying and dividing, so what you need to pay attention to are the total number of sig figs in each of the numbers used. Keep in mind that if you have an exact number, it doesn't come into consideration when counting sig figs. So let's see if we have any exact numbers. As a matter of fact, we do. There are exactly 60 seconds in 1 minute. There could never be 59.5 seconds in 1 minute, for example. So this is an exact conversion or exact value defined number. So we're not even going to take that into consideration when we're counting sig figs. Let's see, the other conversion factor we used was that there are 3.28 feet in a meter. And this is not a defined value. This is somebody went out and with a yard or a ruler or something like that and measured exactly how many, well, not exactly, but approximated, measured how many feet in a meter. And so I'm sure this conversion could be reported with more sig figs. I'm not sure what they would be, but for example, 2.831, depending on the precision of the instrument you use. But in this case, since it's not a defined value, 3.28 has 3 sig figs. So if we look at everything we've multiplied and divided by, the limiting number of sig figs is the given information. And that's usually the case, honestly. So we're limited to 2 significant figures in our answer. So let's look back at our answer. And we can keep 2 digits, so we can keep the 3 and the 5. And that means we need to look at the first digit to the right of the last number we're keeping. And it is a 5, which means we have to round up. So 3.6 feet per second is our answer. I am gradually giving you more and more difficult problems. This is probably the most challenging type of dimensional analysis. Let's say that you were asked to convert units that have an exponent. So for example, this problem is asking you to convert from cubic centimeters to cubic meters. Well, we know that, hopefully, we know the metric prefixes, that 100 centimeters equals 1 meter, but we really don't know the conversion between cubic centimeters to cubic meters. How do we handle that? Well, you have to remember, what does it mean when you cube something or square something? That means that you have multiplied the value by itself 3 times. So centimeter cubed is literally centimeters times centimeters times centimeters 3 times. So when you are doing a dimensional analysis, unit conversion, with something that is squared or cubed, you just have to do the conversion however many times the exponent tells you to do it. So cubic centimeters, we need to cancel out 3 of them. So we do this conversion 3 times, cancel out all 3 centimeters, and then we end up with meters cubed, which is meters times meters times meters, right? Pay attention to sig figs. The given information has 3 sig figs, so your answer must also have 3 sig figs. It's a good idea to get familiar with scientific notation if you aren't already. I accept your answer in decimal form as well as scientific notation. So if you wrote this out as 0.0000357, that would be perfectly fine. Just a little tip in case you've gotten rusty on scientific notation. Anytime you have a really small number, a number that's less than 1, your exponent will be negative. Okay? Anytime you have a number that's greater than 1, a large number, your exponent in scientific notation will be positive. That's it for this lecture. That's it for Chapter 1.